Today I'm going to show you a little trick that I use on my manual mill sometimes to cut an outside radius on a part. Now, this technique doesn't require the use of a specialized cutter like this outside radius cutter, and it also doesn't require you to set up your rotary table, which if you have experience with them, you know they can get kind of involved. So this is a very simple technique. I'm going to walk you through it. It takes very little time. You can cut an accurate radius on a part, and being it doesn't take much time, it'll probably save you some money on a job, and certainly save you some money on, you won't have to buy specialized cutters for a particular job. So let's get started on that, and I hope you find this helpful. First thing I'm going to do here is square up this part in the mill. This is just a piece of scrap I had laying around. It has no other purpose other than just for demonstration for this video. So let's go ahead and square that up. Now my next step is to edge find off of the X and Y surfaces to find my 0,0 origin, which will be in this back corner. First thing I'm going to do is touch off the solid jaw and set my Y-axis to 0 on my digital readout. The Y0 is set, now I need to set the X-axis. So the next step I want to do now is to mark the location of the center of my radius. So let's go ahead and plan for let's say a 1/4 inch radius on this back corner. Now I really can't use a center drill because it doesn't drill a fine enough indentation. It usually leaves a little flat on the bottom, and so you need something with that leaves a real fine divot or indentation in the part. So I use something like this here. You can use a sharpened ground pin, but this is just a tap with a point on it, and I'm going to use that to mark the exact center of this radius. The finer you can make this indentation, the more accurate it will be. So let's go ahead and move off the radius. So I'm going to move off 250 thousandths here. That's what I'm doing right now. On the x-axis and now the y. Okay, we're at 250 on each. Now what I'm going to do is just run this at low speed and put some extreme pressure lubricant on here so there's no galling. That's moly disulfide tapping fluid, by the way. I just use it for stuff like this too. So I'm going to run this at low speed, relatively low speed. And just run that in there a little bit. Just for a few seconds. And now there is a small indentation that I will show you here in a little bit. I'm going to file that off. It leaves a real small indentation on that part. And you can see it right there. It only went down a few thousandths, maybe about 5 thousandths. What I'm going to do now is essentially save the location, the X location of this part, by using a mill stop, a mill vise stop. Now all I have to do is turn this part around, let's say this way, and now I can mark another center of radius here. Now let's make this one 3/8 of an inch. So let's go ahead and do another one. In fact, I'll mark a couple more. think I'll make this one a ½ inch radius. So let's move the Y out to 500 thousandths. Let's say you want to make a custom radius, like you can't get a cutter like this. You can make it whatever size you want, just like on a rotary table. So let's just make it 300 thousandths. So I'm going to turn this around again, and I'm going to take the mill back down to 300 thousandths on the X and the Y. Be able to see here the indentations. Okay, now for the exciting part. That is actually setting up to do the radius. Now I have 4 different center holes in here, or center indentations that I can use. So let's just start out with the smallest one. This would be my 1/4 inch radius. And the point of putting these indentations in here, you can see, is so I can put a pin in place. You see I got this pin in my left hand, and this pin's a real fine point at the end, and that's why I needed to have a fine point or a fine indentation in the steel. That's why you can't use a center drill. So you see when I put that pin in there, whenever I flex this point, or this pin, it doesn't move at all. There's no play whatsoever, and that's what you want for an accurate radius. Now what I'm going to do is put this in the vise and just stick that pin in place and let that rest. Let that pin rest, or let the the pin rest on the movable jaw. And you see I can freely rotate that. Now I need to make sure that this will rotate to my 2 tangents. In other words, my 2 sides that I want the radius to go to. So in this case it's 90 degrees, so I'll rotate it this way and then this way, and so I have clearance. And that's why I was saying this is well suited to small parts. Now if you want to use a bigger part, you'd have to do this on an angle plate. So the next thing I need to do is set the tool height. And to do that, I need a good straight surface here. So I'm going to have to indicate this top surface. I'm going to run the indicator over it to make sure it's straight. And then I'll set the tool height off of that, because I need to figure out, in other words, I need to set my tool height to the tangent of this radius, and that will be this top surface. And being that the center line from here, and being the distance from this surface to this hole is 250 thousandths here, and then also from this surface to 250 thousandths, whenever I go ahead and set this tool height to find my tangent, what will happen is whenever I rotate this part 90 degrees, the cutter will automatically meet up with the tangent on this surface too. So it's once you do one surface, both of them will essentially be set up. So okay, so I'm going to set that in there lightly and gently snug up the vise. Hopefully I can get it close here. It's not close at all. So I'm going to eye that up a little bit and make sure that pin is resting on that movable jaw, and then snug up that vise just slightly. We'll see how close we are. Okay. Okay, I'm 1/1000th low on that side, so that's pretty close. I probably wouldn't even have to mess with that, but I'm going to adjust that slightly. I'm going just to hit that a little bit, and when you do this, make sure you keep that pin in place, because you don't want to, in other words, you want to adjust the level that's not where you have the pin, obviously, because if you push this below center, then it's going to screw up your radius location. So let's just tap that in a little bit and check it out. Now it's low on that side. Okay, it'd be easier if I just do it like this. Okay, I'm half thousandths out. That's good enough as far as I'm concerned. Alright, next. Okay, next I'm going to do something here. Put the cutter in. Use a 1/2 inch end mill here, carbide end mill. I'm just going to drop the cutter down right on top of the part and set the 0 on my knee, and then back off 10 thousandths. And then move the cutter. I'm going to take my Z-axis on the knee here and move it back up to 0. So, whenever I come across here, it should take a light skim cut. Okay, the next thing I'm going to do is put this pin back in the part, right in that pivot point, and make sure that this pin is resting on that movable jaw, and then move this whole part down maybe 5 degrees. It doesn't really matter. About 5 degrees is good. And make sure that that back end is also resting on your jaw, and then snug up your vise just a little bit. Okay, now that's your first cut right there. Now this isn't going to be a radius like you'll get, this isn't going to be a perfectly smooth radius like you get in a rotary table. This is going to be more like a series of line segments that make up a radius. You get that on CNCs a lot too. Instead of a programmer using G2 or G3 circular interpolation commands, what the program will do is draw a series of line segments around a circumference. And this is basically going to be doing the same thing, only not as accurately. So let's go ahead and take his first cut. I actually should have made that angle a little bit more level just for demonstration purposes, but it's no big deal. Okay, now it's just a matter of, once you have that first line segment cut, you loosen up your jaw again very slightly, just put a few thousandths gap in there so it drops, and just let that drop down another, you know, maybe another 5 degrees, something like that, and tighten it back up. And making sure that this pin is dead stop, or make sure this pin is dead resting on this jaw. Then take another cut. Now that left about 100 thousandths line segment up here, and the higher the angle that you index this, the longer the line segment is going to be. So repeat the same thing, loosen up the jaw a tiny bit, move it back. I'm using a piece of metal between the jaws to move that back slightly to get some play. I'm just going to move this back a little bit more, tighten it up, make sure that pin was resting against the jaw. And I caught myself, I didn't have it resting tight up against there. You gotta watch that. There we go. And make sure that's down there completely. Then tighten it up. Okay. We can move to the next one. going to take this out and take some of the burrs off of it before I continue. Otherwise they'll interfere, they'll hit on the edge of that jaw and interfere with what you're doing. This is coming out okay. I see I'm going to go back and clean up some of these. I have some inconsistent line segments on here. I'm going to go back and clean them up after a while. But it's turning out pretty good actually. So let's go to the next one here. And yeah, at this point I'm making really fine line segments. What you can do is you can just file these out. When you're done with the radius, just run a file over them and they'll clean right up. Okay, that one's done. You can see, well, let's see here in the camera. You can see I put a radius on it. It's not perfect, but I have a series of line segments. Some are longer than others because I didn't use a uniform angle throughout the entire circumference. You know, there might be 5 degrees, 10 degrees. The smaller ones are going to be where you have less of an angle between, of course. But it turned out pretty nice. And if you want to finish this off, of course, you just run a file over it. Okay, so that's a 1/4 inch radius there. So let's go to the next one. Okay, I'm just going to stop there. Right there, now we have 300 thousandths radius. There's 250 thousandths, 300 thousandths right there. And I have a series of line segments, you can see them. The first one, I did have a heavy cut there. I must not have that pin pressed down. You have to make sure absolutely that that pin is completely down against there. And if you pivot it up like this, even a few thousandths is going to throw off a cut. So you have to make sure it's kind of angled up to make sure that that part is settled where it's supposed to be. Anyway, there is 300 thousandths right there. Now that is something, if you have a cutter like this, you're not going to be able to, buy a cutter with that exact radius. This is a 3/8 radius here that obviously hasn't been used for a while, has rust on it. So that's 250, 300. I'm not even going to bother filing that now. I'm just going to take the burrs off the edge. Okay, so let's go ahead and cut the 3/8 radius now. Okay, as you can see here, here's the 3/8 radius. Turned out nice. You see a bunch of different line segments on there. You can file the high spots off of that one. I was going to show you the whole video of cutting that, but what happened is my camera ran out of memory, so I had to unload that and start over again here. But I'm going to show you the 4th radius here, and this is the 1/2 inch radius. So this should be interesting. Okay, here is the last radius, and this is the 1/2 inch radius here. Now I made this one a little bit higher resolution. In other words, I made the line segments smaller. Up here they're about the same as the other ones, but I decided to make it a finer cut. So I broke it up into smaller angular moves, and you can see these line segments are really small. In fact, it's almost not a perfectly smooth radius, but it would take very little filing over those high spots to break that into a really nice smooth curve. So that is one way I cut an outside radius on a part, and you don't have to worry about having the proper cutter like that or rotary table.